Week 1, Lecture 7, Variables in Julia. They have a name, a value, and a type. So computer programming can be summarized very concisely as the art of creating the right types in the right variables at the right time. So we want to talk today about how variables get their values and what the valid variable names are, and the question of types when it comes to variables. We'll use array types to illustrate some of that. So let's start by talking about array types. Julia has excellent support for arrays. It's as good as MATLAB, and they're very easy to create. We have a function called array, and it generates for us an array. Here we see this 3 ends up with 3 values. These are all integers in here. They don't mean anything. If I were to run this again, I would get different values. The type is also array, but it's using braces. So this is a type. It's an array type. It has one dimension, which is one vertical column, and there are 3 elements. So it's really important to notice the difference between this 1 here, which is the number of columns in the array, and this 3 here. Although it's in 64,1, in 64,3, they mean different things. This 3 means the number of elements in the first dimension. If we had a comma 2, there'd be a number of elements in the second dimension, and so on. The int 64 here says that every element in the array is going to be int 64, and this is in fact what this int 64 also says, that every element in the array is int 64. Right. The right value in the right variable at the right time. But how do variables get their values? It's the operator equals sign, a single equals sign. So here is a variable named greeting, and it gets the value hello world, the string, as follows. We can print this. So what's happening here is that the name of the variable here sends the value of the variable to println, and print, which is a string of course, and println then prints the string as it's done for us before. Here's a very important warning. You can easily get lost between using the single equal sign and the double equal sign. The single equal sign is when you do assignment. The double equal sign is when you do comparison. Unfortunately, these two are similar. You just have to work out whichever one is intended. This is a legacy from the older programming languages. Mistakes will occur. It's one of the most prolific sources of bugs of all. But that's all there is to assignment. We have this equal sign. Okay, so valid variable names in Julia. A valid variable name is almost any string that starts with a letter and continues with letters or numbers or other characters. The letters can be any Unicode characters. We can use Mandarin, Ren, Shang, and that can work. So we could name all our variables in Mandarin. We could have a program that looks almost entirely as if it is written in Mandarin, except for the reserved words that would be written using Roman letters, recognizably English. But here's a 2-element array. Notice how we use the square brackets to find the array, and it has the 2 values 20 and 11.1 because we used the variable Ren and Shang here. It is actually valid to use an initial character that's not a letter, so it gives us this value. We're happy with that. We can also include exclamation mark anywhere in the variable name, but the community standard is to avoid that. The community standard is just to use lowercase letters without any underscores, without any exclamation marks. And this is because variables that start with underscore play a role in the Julia internals, and variables and functions that end in exclamation mark have a special quality, namely they modify their arguments. Finally, when it comes to capitals, they get used in type names and module names. And so that's why, as far as style is concerned, it is discouraged to do this sort of thing. the three parts of a Julia variable. We said that every variable in Julia has a name, a value, and a type. The assignment operator binds the name to the value, but there is this third item, the type, and we have said that only values have types. So in what sense do we want to say that a variable has a type? So if it's a concrete type, the variable has a definite value, and then the concrete type of the value is also the concrete type of the variable. But we often refer to a variable only by its name. In that case, we don't know the value, and therefore we don't know the type. It may even be that the value has not yet been created. So when we say println greeting, greeting may not have been created, and so it doesn't have a type, and we cannot say what it should be. A variable that is known only by its name is given the abstract type any, because every single value in Julia must in some sense be part of the abstract type any. We don't have to jump directly from a concrete type to the abstract type any. We can jump, say, from float64 to real and so on. But if we want to refer to these variables without knowing what their type is, we can refer to them in terms of one of their supertypes. So that is actually very useful. If we try to use a variable with an abstract type before it is actually given a value, there's an error. So we can summarize all of this as follows. It is slightly wrong to say that a variable has a type. The value of the variable has a type. It's just that while a variable waits to have a particular value and therefore a concrete type, it can be useful to have in hand a limited set of possible types this variable can have, and for that we use abstract types. Right, so let's look at an example of a variable with an abstract type at the moment it is created. We use the function array again, but we give it a type which is abstract. Just to be interesting, we'll have 2 in the first dimension, 3 in the second. That means 2 rows, 3 columns. And the interesting result is that it is created, but there are no values. They're all undefined. They're kind of empty. There's nothing there. If we try to access any of those values, this is where we introduce how we access the values in an array. We use these brackets, square that is. So, of course, that doesn't exist. So saying that we want row 2, column 1, that one there, must be an error because it doesn't exist. However, we can in fact assign a value to the variable. The value 1 is now assigned. It just says that there's a value 1 and it's been assigned. Abs-type variable is still an array of type integer, although the one value that has been defined would be int64, the rest isn't. Suppose we try to assign a value which is not an integer but can be converted to an integer. So now row 1, column 2, we try to assign 5.0, and what happens is that it says 5.0, but if we look at abs-type variable, it is actually an integer that comes up. Julia will do such conversions whenever it can in order to keep your program running. If it has to do lots of conversions, it might be a problem for speed. On the other hand, if you try to do an assignment which cannot be converted to an integer, then you will in fact see the error. Convert cannot convert ASCII string to any type of integer. And there's a long error message, but the important part is right there. There's no method that starts with ASCII string. It says it was here, the in21, the expression that starts in line 1. There's only one line in this cell, and so that was all it can refer to. Now, it is often a good idea for you to create a variable before you're going to use it with concrete values. And then we do as we did at the beginning. We can create an array, 2 rows, 3 columns, and again, these are basically randomly assigned variables. Let me repeat the reassurance I gave when we started talking about types. We can almost always ignore types when we write Julia code.